name is Jake Frada. This is Professor Charles, and you will be learning today about electromagnetic propulsion. At the end of this video, I want you to smash that like button, subscribe. Hello. Today we will be learning about electromagnetic propulsion, or also electromagnetic acceleration. In its simplest terms, it is the acceleration of an object through electric currents and magnetic fields. It was first discovered by Elihu Thomson in 1889. Now, let's delve deeper into electromagnetic propulsion. Now, I know this may sound scary, but it's actually much easier to understand than you might think. To show the basics of what is happening in this concept, I'll draw out what is actually happening. Crap, wrong formula. In all seriousness, the way an electromagnetic propulsion system works, or in this specific case a railgun, it has two electrically charged rods with positive and negative side, and it has electromagnetic fields going around both rods like this. Now these rods and these electromagnetic fields are what propel an object. And this object being any kind of metal, sphere, or missile, or any kind of metallic object. In this case, we'll use a ball. When pushed through with an exterior force, accelerates through the magnetic field and the two rods, and speeds up and goes out the other end. There's also another type of electromagnetic propulsion. This is called the Gauss rifle. The Gauss rifle has two neodymium magnets attached to either end. These are very, very strong rare earth magnets. They also have a magnetic field that surrounds them. Here, and here, and here, and here. These magnetic fields act as an attraction and a repulsion device. So, if a ball, in my case I'm using an aluminum ball, were to be pushed towards this magnetic field, the magnet would attract the ball and repel this ball on the end. This would happen again with this magnetic field. This ball would be attracted to this magnet, and this ball would accelerate at an even faster rate than this ball or this ball did. This is a real-life version of a Gauss rifle. You can see with the sequence as on the whiteboard: magnet, ball, ball, magnet, ball, ball, and so on. Now, if I put this magnet onto the ruler here, it will have a chain reaction and shoot this end ball out. This is because of the kinetic energy in motion that the balls are getting through the magnetic fields of the magnets. Now, let's see what it can do. Okay, pretty cool. When the magnet is given its initial thrust force, which is the force acted upon the object with my finger, it is then accelerated towards the magnet, which is pulling it with its magnetic fields. This is a real-life version of a Gauss rifle. You can tell with the sequence of magnet, ball, ball, magnet, ball, ball, and so on. Now, if I use this ball here and put it onto the Gauss rifle and push it forward, there will be a chain reaction, and this ball comes out at the end at a faster pace than it did when I pushed it. This is because with my initial thrust force acted upon with this ball by my finger, it is then pulled in by the magnets and then pushed out. This creates more kinetic energy through the motion and accelerates the balls to a faster rate than when it started out with. Now, the acceleration of the projectile would be much easier to chart if it weren't acted upon by external forces. One of these external forces is air resistance. Air resistance is the force acting upon the projectile when the projectile is in motion. Also, friction is acting upon the projectile while it is in contact with this ruler. This makes it difficult to keep track of the speed of the projectile, but if you use the kinetic energy formula, you'll be able to see what speed the projectile is shooting off at. Besides from these small applications, the military has also developed their own railgun. These are very powerful and can conduct enough energy to deliver a 2 kilogram payload to a maximum velocity of 3 kilometers per second. This would be enough to penetrate a tank and even pass through it. Wouldn't that be awesome? To see a missile pass through a tank? But bigger and more powerful. Now, let's look at some military testing of the railgun.
Anyone? Fire.
Learn something about electromagnetic propulsion. An idea that you probably had no clue and were very intimidated by the first time you saw it. And you can tell me why this ball is propelled and makes that ball go a little bit faster. Thank you. Hit that like button below and subscribe.